Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning because I wanted to give you another code review. And this code review is going to be similar to the last code review that I did. The last code review that I did was on horses and humans, and this was a binary classification, and this code review that I'm going to do is going to be on the iris datasets, and it's going to be on a multinomial classification. But what I'm going to do, is I'm going to copy the link, and I will leave a link to the Jupyter notebook in the description box down below, and so that way you can call up the Jupyter notebook and you can follow along with me. I have to be a little bit quick because I'm getting ready to go somewhere in a few minutes, but we're going to go over the iris dataset, which is similar to the humans and horses dataset, except the humans and horses dataset had 2 classes, whereas the iris dataset had 3. And in both datasets, we used the softmax activator. So I got this off the Kaggle. Problem statement is classify iris images based on the Fisher dataset. So these are iris images. And then what we're going to do, and I did actually tidy up the code a little bit. So the code in this dataset, this code review looks better than the code in the horses and humans code review because, I've been working a lot on particular data sets to try to build up my cache. I don't know if that's the correct word, cache of data sets. And I just have a small little laptop, and so it doesn't have enough power and memory to store images, and that's why I have to use Kaggle. And before we do the code review, I want to let you know that I got one comment, and I'll go ahead and go through this comment. And he says, keep doing, bro, and improve your model. Well, number one, I'm not a bro. I'm a sis. And 2, I did actually work on the model this morning to try to improve it, but the efforts that I took were not successful. And because the efforts that I took were not successful, I had to go through and use the model that I had used previously. But there are things that you can do to improve the model, like you can change the number of features, you can change the batch size, you can increase the number of epochs, you can change your activation functions, you can use a different optimizer. So those are some things that you can do to try to improve the model. But because, obviously I can't work endlessly on one data set, so I have to sometimes accept things as they are. But if you're working in industry, then you're going to have to carry out all those different techniques to try to improve your model, because you're going to want your accuracy to be as high as possible. But what I'm doing here is I'm just giving you the code, and I'm getting the code as good as I can at the moment, and then you can go through and try different things to improve your accuracy. You also can change your learning rate. That also can improve your model. So now that we're going to go through the Jupyter notebook, the first thing we'll talk about is the library. So you're going to need to import a lot of libraries to get this program to work. So you're going to import NumPy as NP. That creates your NumPy arrays and performs numerical computations. You're going to import pandas as PD. That's going to create your data frames and perform data processing. You're going to import OS, and what that does is that goes into your operating system and carries out functions. You're going to import path_lib, which is going to create a path that your files are going to be in. You're going to import matplotlib.image SIMG. That's going to help you visualize the images. You're going to import pil.image SIMG. That's going to help you work on the images as well. You're going to import CV2, which is computer vision, and that's going to work on your images as well. You're going to import JAX, which is going to create JAX arrays and perform numerical computations. You're going to import Flax, and that's what you're going to be using to create your CNN, convolutional neural network. You're going to import not_optax, which is going to give you your optimizers. You're going to import sklearn, which is going to provide you with machine learning functionality. You're going to import matplotlib.pyplot as PLT, and I just import that as a matter of course. And you're going to import Seaborn, and matplotlib and Seaborn are visualization libraries. So after we have imported our libraries, we're going to use the OS function. And what the OS function does, it's going to call up all of your images. So we've got all of the images called up in the OS function. And so there's 3 classes. So there's of iris. So there's 1 image for each class of iris. And so we go down here. So now we're going to create our directory path using path_lib. And then after we create our directory class, we're going to define our classes, and we have 3 classes of Setosa, Versicolor, and Virginica. And so that gives you your 3 classes. So Setosa is 67, Versicolor is 269, and Virginica is 85. So you have more Versicolors than you have anything else. And probably in order to make the program work better, if we had just had 50 of each, that may have made the program work better, because in the actual iris data set you've got 50 of each, and this one, because you've got a Versicolor of 269, that means you're going to have more Versicolors of anything else, and so that means that the computer is going to automatically select that. So what I might do later after I finish this video is I might go through and trim down all of the images to 50 each and see if that actually improves the score, because at the moment we have more number 1s than we have anything else. And then after we have defined the lengths of the images, then what we're going to do is we're going to select a random number for each image, and then you can actually see a picture of the Setosa, the Versicolor, and the Virginica, because I like to have pictures in my videos. I think it's pretty. Now what we're going to do is we're going to define the data frame. And so you've got your images of Setosa, Versicolor, and Virginica, and then you've got your labels as Setosa 0, Versicolor 1, and Virginica 2. So we're going to get the shape of the image using CV2. So you can see that the shape of the image is 256 by 256 by 3. Then what we're going to do is we're going to define the variables X and Y. X is your images and Y is your labels. And then we're going to resize the images to image 244, 244. And then we're going to print the length of X and Y, and it's going to be 421, 421. We're going to define the classes. which is the length of the number of unique values in y, and so it's going to be 3 classes. We're going to convert the x and the y variables to Jack's arrays, and then what we're going to do is we're going to normalize the x variable, which is your images. And then when we normalize the x variable, what we're going to do is you're going to take all of the images, the numbers in the images, and you're going to convert them to a value of between 0 and 1. And so we use the normalization formula for that. Then I'm going to use sklearn to break down the x and the y variables into training and testing sets. And then after we've broken down the x and the y variables into training and testing sets, we're going to convert xtrain, xtest, ytrain, ytest into Jack's arrays. And then we're going to check the shape of that as well. So now what we're going to do is we're going to define the convolution neural network, and this is the same formula that I had used on the horses and humans data set. And actually I was doing some work this morning and I was trying to put some more bells and whistles in the formula, hoping it would work better, and the bells and whistles didn't work, so I had to go back to using the same formula that I had previously used. And so now what we're going to do is we're going to define our model as the CNN, the convolution neural network, and then we're going to print off the different layers. So you've got CONV1, CONV2, CONV3, and dense. So now we're going to predict on the training set, and we're going to the first 5 rows of the training set. And so you can see that the prediction has 3 columns of data, and the reason why it has 3 columns of data is because there are 3 classes. And what it's going to do down later on in the program, it's going to use the argmax function, and when it uses the argmax function, it's going to select the column that has the highest value. So 39 will be the highest value in column 0, 37 will be the highest value in column 1, 38 will be the highest value in column 2, 36 will be the highest value in column 3, and 34 will be the highest value in column 4. And so what they'll do is it will select the column with the highest value. Okay, so now what we're going to do is we're going to define the function for the loss, and you can see whenever you define the function for the loss, you can see that the actual value has actually been 1-hot encoded. And the reason why it's been 1-hot encoded is because the actual value has 3 classes in it, so it has to be 1-hot encoded to have 1 column for each class. And then what we're going to do is we set up our training function, and now what we're going to do is we're going to actually train the model. And so we're going to have a batch size of 64, 15 epochs, and a learning rate of 0.0001. And so we train the model, and you can see that when we have our 15th epoch, it goes down to 9.184, and if we had more epochs, there's the possibility that the loss would have gone down even lower. So now we're going to make predictions on the training set and the testing set. And so you can see here we have the prediction function, and then we actually make the predictions, and you can see what we've got for the training set and the testing set, or the testing set and the training set. So we check our accuracy. For the training set, we have an accuracy of 96, and for the testing set, we have an accuracy of 51. And obviously, that's not fantastic, and that can be improved. And then we do a classification report, so that just gives you a little bit more information about the goodness of fit of the model. And then we use a confusion matrix, and the confusion matrix tells you which values, which predictions you got right and which predictions you got wrong. And so what you can do to actually improve the score is you can change the learning rate. You can experiment with the learning rate. And if you experiment with the learning rate, then that might improve your score. You can experiment with the optimizers, because at the moment we're using the Atom optimizer. And in the previous video I did, it used the SGD optimizer, but you can experiment with lots of different optimizers and try to use the optimizer that's going to give you the best level of accuracy. You can also experiment with batch size. Previously I had a batch size of 32, but it didn't work with a batch size of 32, so I have a batch size of 64. You can increase the epochs, because the more epochs you have, the better your error is going to be, or the less the error is going to be. So there's lots that you can do to actually improve the score. And what I'm going to do when I finish this video is I'm going to try to make each model only 50 images, and see if that model has only 50 images, because at the moment we have an imbalanced data set, and the idea is to try to get the data set balanced. So I'm going to go ahead and include this video because I've done the code review. I've told you everything I've done to create this program, and I've told you what you can do to improve it. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video. I'm looking forward to making more videos for you in the future.